Hi, my name is Rajveer Singh and I'm a 10th grader at Peachtree Ridge High School. In my project, I created a new water treatment process which removes 98% of microplastics and 82% of bisphenol A, also known as BPA, from water. This unique process of combining both BPA and microplastic removal has never been done before. Microplastics are plastic debris 5 millimeters or smaller, and BPA is a harmful pollutant from plastic products. In my experiment, I treated water contaminated with BPA and microplastics with first magnetite to remove the microplastics, and second activated carbon to remove the BPA. Magnetite and activated carbon are naturally occurring, non-toxic substances. I tested this process using 3 different sizes of microplastics in order to mimic the real sizes of microplastics in our environment. My extraction process is 10% more effective than other known treatments for microplastic removal, and it's also cheaper and easier to do than current methods of BPA removal since it doesn't use harsh acids and chemicals which toxify the environment. I've also been doing additional experimentation to further cost optimize my methods so I can clean up to 500 gallons of contaminated water with just $1 worth of materials. My microplastic extraction process and BPA removal can be done in minutes and should be implemented into wastewater treatment plants and aquatic farms worldwide. I developed my project by analyzing one of the main issues in our society, water pollution. 80% of wastewater from homes and corporations enters the environment untreated, and this water contains microplastics from common sources such as tires, plastic bags, bottles, and other everyday items. These microplastics are lined with BPA from the manufacturing process, and this BPA leaches into the water. Humans consume over 74,000 pieces of microplastics yearly. According to the Mayo Clinic, microplastics can leave lesions in your digestive system, and BPA leached from these plastics impair babies' brain growth and can cause Alzheimer's and heart disease in adults. BPA is currently not being removed from water treatment plants because the negative health effects of BPA were only recently discovered. Microplastics are similarly not being targeted by wastewater treatment facilities. In order to fix this, I innovated a brand new process to remove both microplastics and BPA concurrently. In order to develop my project, my goal was to improve upon past experiments in the literature to create a more effective, safe, and faster extraction of both BPA and microplastics. I researched how magnetite ferrofluids, which are magnetic fluids, can remove small particles in water by surrounding them with magnetite particles, which can then be removed via magnets. Previous experimentation for microplastic removal used oil, but it's difficult to remove oil from water. In order to change this, I improved upon this process by removing microplastics with magnetite only. I also researched how activated carbon can create dipoles in neutral organic molecules, including BPA. These dipoles cause the molecules to attract BPA and get trapped inside the pores of the activated carbon. The powdered activated carbon can remove more contaminants with higher surface area. Previous experiments for BPA removal use activated carbon treated with acids and chemicals overnight, which can't be converted into drinking water and make the water toxic. I improved this process by using pure powdered activated carbon. Part 1 of my methods was the microplastic removal using magnetite. The independent variable were the 3 different sizes of glitter that I used, and the dependent variable was the percent mass of glitter remaining after each removal. The control group was no glitter extraction. On the left, you can see I've included a video of me conducting my methods. I added 250 milliliters of water, 0.3 grams of microplastics, and 5 grams of magnetite. Then I stirred vigorously for 1 minute. The reason I stir is that the particles of magnetite will now surround the microplastics, so when I pass through with a magnet in a test tube, the magnets will pick up both the magnetite and the microplastics. As you can see, I pick up the test tube and the magnetite and microplastics are attached. I repeated this process 3 more times for a total of 4 times, and as you can see, the water got clearer and the microplastics have been removed. This was the red glitter extraction, and on average, I removed 99% of all microplastics using these methods. For the BPA removal, part 2 of my methods, the independent variable was activated carbon extraction of BPA. The dependent variable was the absorbance colorimeter reading. BPA absorbs light in a solution, so by the amount of light that was passing through in the colorimeter, I could see how much BPA was left in the solution. The control group was BPA in water without being removed, which I used as a baseline. The reason activated carbon can absorb BPA is because of adsorption. BPA molecules will stick onto the surface of the activated carbon and enter its pores, which is why activated carbon is so good at absorbing toxins. Here are my methods. I calibrated the colorimeter with the control group, which was the BPA not being extracted. I used this as a baseline. Then I dissolved 0.07 grams of BPA into acetone since BPA is not soluble in water. I then added the solution to distilled water and poured the solution over 20 grams of activated carbon in a coffee filter. I sampled the solution with a cuvette and tested the colorimeter absorbance value. I then disposed of all the water safely at the chemistry lab in my high school since BPA is toxic. Here's the data analysis. After 30 trials, I removed over 82% of BPA. As you can see on the scatter plot, the BPA trials without removal were close to 0% and 0 overall removal. However, after straining over activated carbon, you can see I have an average of 82% removed. The bright green star is my average value of 82%. The p-value is less than 0.05, meaning that my results are very statistically significant. Here's the data analysis for the microplastic removal. Again, the p-value is under 0.05, so it's statistically significant. I removed 98, 96, and 99% of microplastics, respectively. Over 60 total trials, 20 trials per glitter size. I strained the glitter solution over a paper towel in order to count and then mask the glitter in all trials. The third part of my experiment was the cost optimization. Optimizing the amount of magnetite in my experiment is important because I can drastically lower the cost while maintaining efficacy. As you can see by the graph, at 5 grams, 2.5 grams, and 1.25 grams of magnetite used, the results were similar. We started to see a drop-off at 0.75 grams and 0.3 grams of magnetite used. This was after 40 total trials testing 5 different sizes. Just $1 of magnetite can purify over 500 gallons of water. And again, my p-value was statistically significant at less than 0.05. One of the main applications for my ideas is in wastewater treatment facilities, because wastewater treatment facilities do not currently have a distinct stage to weed out microplastics or remove BPA. My application could be in the secondary clarifying stage of wastewater treatment, which is where small debris, including microplastics, and chemicals, including BPA, could be removed. Another ideal application for my project is in aquatic farming. Aquatic farming is ideal for my microplastic and BPA extraction because it's a controlled environment where seafood are raised and then humans consume them. Over 73% of all seafood, including fish, mussels, shrimp, etc., contain microplastics, and it's one of the largest ways and main ways that humans consume microplastics. If we could clean up aquatic farms, that would ensure that humans' food sources would remain free of microplastics and BPA. The levels of microplastics and BPA in our environment are irreversibly increasing. My idea should be funded because the process of combining BPA and microplastic removal has never been done before. My process is significantly more effective, cheaper, and easier to implement than existing ideas. Once I receive the funding, I plan to further execute my idea. First, using the funds provided by the Innovation Award, I will buy additional materials and continue trials focused on cost optimization and process efficiency. Second, I plan to use the expertise of industry professionals from the Innovation and Action Expo to legitimize my idea. This will help me approach third-party users, such as aquatic farms and wastewater treatment facilities, with my innovative process. My treatment process is, one, attractive to businesses because of its profitability, because of the licensing model. And secondly, it's beneficial to people. It removes harmful contaminants from their water. My idea secures profit through licensing the unique extraction process. In order to accomplish this, I will get a patent to protect this process, and then third-party users can license this technology for their own customers. This is a strong business strategy because it's scalable and can be implemented nationwide. My project should be selected to receive these funds because I have a clear plan to utilize the new capital. And with such cost-effective methods, the Innovation Fair Prize will help me exponentially improve this project and idea. This is a cause I'm passionate about, and I hope all of you are excited to clean the environment with me. Thank you for considering me for the Innovation Award.